Welcome to The Explainer. Today, we're diving into Cisco's SD Access Fabric, and we're going to see exactly how it handles wireless networking. We're going to break down the architecture, meet the key components, and walk through the entire process you need to know to get this deployed smoothly.
All right, so here's our game plan. We're going to start with the fundamental rules of the road, the stuff that makes this whole system tick. Then we'll meet the core components, the main players. After that, we'll get our hands dirty with the hardware integration, set up the network for our users, and then we'll follow a client on its complete journey from connection to roaming.
Okay, first things first. We have to lay the groundwork. Before we even think about plugging anything in, we've got to understand the architectural principles that make Fabric Wireless work. These aren't suggestions. They're the non-negotiables of the entire design.
So here's the most crucial thing to get your head around: how the pieces are laid out. Your wireless LAN controller, the WLC, actually lives outside the fabric, but it talks to the fabric's brain, the control plane, using a protocol called Lisp, which is basically a fancy map for network locations. Meanwhile, your access points, they live inside the fabric. And this whole design has some really strict rules, like that sub-20 millisecond latency requirement. That's there to make sure the conversation between the WLC and the APs is always lightning fast. So with those rules in mind, let's meet the key players that bring this all to life. In our Fabric Wireless story, there are really three main characters you've got to know: the controller, the access point, and of course, the client.
First up, the WLC. You can just think of this as the main operations manager for all things wireless. It sits just outside the fabric, connected through the regular network underlay. Cisco DNA Center gets it all set up with the right credentials so it can have a secure chat with the fabric's control plane to handle all the device registrations.
Next up, the access points. These are our boots on the ground, providing that connection directly to the users. Now, what's really cool here is this idea of the infra VN. It's a special overlay network, and it means all your APs, no matter where they are, live in one single simplified IP subnet. This just completely changes the game for IP design. It's a massive win for anyone managing a large deployment.
And finally, our clients. The laptops, the phones, the whole reason we're doing this. In this model, all the network smarts for the client get pushed right out to the edge switch they're connected to. And this right here is one of the Fabric's biggest benefits: truly seamless roaming. Since the gateway is right there on the switch, traffic doesn't have to hairpin all the way back to a central controller. A wireless user can talk directly to a wired user sitting next to them. It's pretty brilliant.
All right, we know the players. Now let's get to the how-to. This part is all about the technical process of actually integrating the hardware into the fabric. And it all kicks off in Cisco DNA Center by telling the network about your WLC and your APs.
Getting the WLC into the fold is actually pretty straightforward. You just provision it in DNA Center, you tell it which fabric site it belongs to, and that's pretty much it. DNA Center takes over, pushes all the configurations and security credentials, and poof, the WLC is now fabric-aware and ready to play its part.
Now, adding an AP is a little more of a dance, but don't worry, it's highly automated. Phase 1 is all about discovery. You start by setting up an IP pool in that special INFR VN we talked about. Then, you just physically plug an AP into an edge switch. The switch sees it, hands it an IP address from that pool, and then tells the control plane, "Hey, I've got a new AP here."
The process wraps up with the registration phase. The AP finds and joins the WLC. The WLC then checks with the control plane, kind of like asking, "Hey, is this AP for real? Is it part of our fabric?" Once it gets the OK, the WLC does a special Layer 2 registration, and that's the signal for the edge switch to build a dedicated data tunnel using VXLAN directly to that AP. Once that tunnel's up, it is officially open for business.
Okay, the hardware's all in place, and it's fabric-aware. Let's move on to the final config steps we need before our users can actually connect. This is all about prepping the virtual networks and the SSIDs that people are going to see on their devices.
So the process here is pretty logical. You create an IP address pool just for your wireless users, then you link that pool to a specific virtual network, which lets you segment traffic for security. And finally, you tie that whole package to the SSID that users will actually see and connect to. You hit deploy, and the wireless network is live.
Now, I really want you to pay close attention to this, because this is one of those details that can trip you up. Enabling the Layer 2 extension is not optional. Let me say that again. It's mandatory. This is the little checkbox that tells the fabric, hey, stretch this network across all the edge switches for these users. It's the magic switch that makes that seamless roaming possible. You forget this, and the whole thing just won't work right.
All right, we have built the foundation, we've integrated the hardware, we've configured the software. Now for the payoff. Let's actually watch a client's journey as it connects and moves around inside our new Fabric wireless network.
This is really the moment where it all comes together. We've done all this prep work, but what actually happens under the hood when a user opens their laptop, sees your SSID, and clicks connect? Let's break it down.
It's a super fast four-step sequence. First, the client authenticates, and the WLC gets what's called a Security Group Tag, or SGT, from your policy engine. Think of it as just a policy label. Second, the WLC shoots that info down to the AP. Third, the WLC registers this client with the main control plane, and finally, the control plane taps the local edge switch on the shoulder and says, here's the policy you need to apply for this user.
And this is the big win. This is why we do all this. When a user walks from one AP to another that's plugged into a totally different switch, the new switch just tells the control plane, hey, this client is with me now. And because the network gateway is the same on every single switch, that's the Anycast gateway, the client keeps its IP address. The session never drops. To the user, it's completely invisible. That is a true, seamless Layer 2 roam.
So there you have it. That's how you build a really powerful, automated wireless network on top of SD access. I think the key thing to take away from all this is that this amazing intelligence at the wireless layer absolutely relies on a solid foundation. This process makes wireless management so much simpler, and the user experience so much better, but it all starts with a well-designed network underlay. Thanks for joining this Explain.